First thing you're going to do, yes, calculate the percent of the molar mass that is for the specific element. Step 2, divide by the molar mass of the element. Round answer to nearest whole number. And this is the subscript for that element. So if you put it all together, the answer that you get is the molecular formula, and you reduce that to get your empirical formula. Compound's molar mass is 180.18 grams per mole. The percents for the elements are 40.03% carbon, 6.67% hydrogen, so you have to take the molar mass, multiply it by the percents, divide it by the actual molar mass for the element, and that will give you your ratios. So for carbon, you have to take the percents and put them over 100. So now, take those numbers and you divide by the molar mass for the element. So the first one will be divided by 12.01, second one 1.01, and the last one 16.
First one's 6. Last one's
6.005.
6.
But you round it off.
All right, so it's just 6.
So that gives you your molecular formula. Reduce it, and you've got your empirical formula. There we go. So that is how you're going to do it when you...
On my lip.
Okay, mole ratio is just ratios, guys. We're going to use this for the next little bit. Ratios of reactants and products from
Are you serious right now?
Answer the phone.
This is tough.
Answer an unknown number.
Yeah.
That's
a balanced. So, mole ratio, ratios of reactants and products from a balanced chemical equation. So you've got a balanced chemical equation there. This is right here.
Oh, that's easy.
Carbon plus 2 chlorines makes carbon tetrachloride. So you need a balanced chemical equation because you use the coefficients. You use the numbers out front. So you can set up a ratio of carbon to carbon tetrachloride. What's the number in front of carbon, Angelica?
2, 1, 2. Wait,
Carbon.
2 is 4. No, that's 0. 4. What?
1.
1. I don't know what we're doing, though.
Because you're not paying attention, so pay attention. Well, wait.
That was important.
This is important too. Okay, what's the number in front of carbon tetrachloride?
1.
1. So 1 carbon makes 1 carbon tetrachloride. You can do a ratio of chlorine to carbon. What's the ratio?
2 chloride and 1 carbon.
2 to 1. You can do a ratio of carbon tetrachloride to chlorine. What's the ratio?
One.
Over
2.
2. You put down the ratio of the chemicals that you want, and the number in front of them from the balanced chemical equation goes in front of them. That's called a mole ratio. And we're going to use them. So put 16.5 grams underneath the carbon.
That's little m.
No, it's under the carbon, not the M.
Oh no, it's beside it.
So you get a little over 1 1/3 moles.
Sorry, what did you get?
1.37, so a little over 1 1/3 moles.
Yeah. Set up your mole ratio. You're going to put what you have on the bottom, what you want on the top. So carbon has 1, chlorine has 2. So once you use your mole ratio to give you the moles of the other compound, multiply it by its molar mass to give you the mass. There's only 3 steps.
Yeah, 1 and 2.
Yep.
I kind of recognize this.
95.684.
1,
Oh, 194.
90, what?
95.68.
I got 194.69.
Okay, so I'm going to make it in between 195. Okay, so first step. We've got information about carbon monoxide, so we're going to calculate the moles of that. 19.29 divided by 28.01 will give us the moles of carbon monoxide. So now that we have the moles of iron, multiply this out,
I'm like, this one.
and that will give us the mass of iron you can make. So 0.458 times 55.85.
25.57.
So we're going to round that up. Oh,
5.57.
that works.